All right, so modeling the reheat is fairly simple. So we'll go to this tab. Um, the reheat is just a flow in and out, and I have some heat transfer in. So it's one inlet and one exit. So my mass continuity equation just simplifies to mass inlet equals mass flow rate at the inlet equals mass flow rate at the exit. So I can just call that m dot. And then if it's steady state, no change in kinetic, no change in potential, no work or power. There is heat transfer. So let's then write out my first law. 0 equals q dot minus w dot, which is 0, plus m dot, h at the inlet and h at the exit, h inlet minus h exit. So if I bring this term to the other side of the equation, I have q dot equals m dot h exit minus h inlet. So it's really quite simple. My inlet enthalpy, probably I'm given temperature and pressure. So from those I can find the inlet. And then typically at the exit, what I'm given is temperature. So each exit would be a function of the temperature that's given. And then the pressure at the exit is the same as the pressure at the inlet for this open, this is open to a tank, so the pressure won't change across here. If it did, it would drop slightly, but we'll assume there's no pressure drop there. So we can easily calculate this one. So the state will change. It's being heated, so it equals whatever this is plus 1. And we have to calculate the properties here like we've been doing. So pressure and enthalpy are known, so equals water, pressure, enthalpy known. I want temperature. Pressure's here, enthalpy's here. Just going to copy that and paste it. Don't know why I didn't put parenthesis there. All right, so copy that. And still didn't like it. There we go. Apparently, there we go. And this one I want to be entropy. So this one, pressure and enthalpy, find temperature. Pressure and enthalpy, find entropy. This is the quality, where I give the pressure, actually, equal x, specify the pressure and the enthalpy. And all the inlet conditions are good. Now the exit, I'm going to specify the temperature. So let's put 600 degrees. The pressure just equals whatever this pressure is. So now I know temperature and pressure, and I want enthalpy. So equals water, temperature and pressure. Find enthalpy. Here's the temperature and the pressure. And then I could do the same to find entropy, so let me just copy that. Paste it here. Except change this to entropy. And then the quality again, x, this pressure, and this enthalpy. So it was superheated, now it's even more superheated, and then the mass flow rate doesn't change. So this. And then finally, coming over here, we implement our equation. So Q up here equals m dot times H exit minus H inlet. And the reheat's easy. Now, the steam boiler is almost exactly the same, just one inlet, one exit, and Q in. The condenser is similar, but we have two inlets, one exit, and heat transfer. So the only difference is like a reheat, except we have two inlets, or like a steam generator and we have two inlets. So it'd be just like the reheat, except over here we have another m dot delta H coming in. So it'll be, well, really two inlets and one exit. So just write that out. So for the condenser, we have these two inlets and one exit. And what we know is that the exit always is saturated liquid. So we know what the state of that is. We know this mass flow rate and this enthalpy, and I'll call it state. Let's see. Guess I can't see the top there what state it is, but this is state 1, 2, well, let me go to the example. So it's state 5, m dot 5, H5. This one's not labeled, but if it was, maybe it'd be 13. So m dot 13 and with an H13. Of course, it was coming in here, it would be these values, so it would just be these. This term here is the mass flow rate times the enthalpy already multiplied together, so that's coming in there. And then this is coming out here. And that will be then the sum of the mass flow rates of those. So m dot, if this is 6, m dot 6 equals m dot 5 plus m dot 13. So the mass flow rates, the mass continuity equation, so 0 equals summation m dot I minus summation m dot E. So we have, we're solving for the one m dot E. So we have 0 equals m dot 5 plus m dot 13 minus m dot 6. So that's how we're solving for that. And then our first law has summation m dot I Hi minus summation m dot E He. So we do that for each inlet and ultimately then solve for He. And you can use this expression to solve for that. So it's not much different. So now you have all the information you need to build all the components of the power plant.